Good morning, students. Now I am going to talk about the basics of operational amplifier. The topic discussed are introduction of operational amplifier, block diagram of operational amplifier, symbolic representation of operational amplifier, ideal operational amplifier, and practical operational amplifier. Before studying about operational amplifier, we should know what is an amplifier. An amplifier is an electronic device that amplifies or increases the voltage, current, or power of a signal. The amount of amplification provided by an amplifier is measured by its gain. In an amplifier, the gain should be greater than 1. Okay, so the amount of amplification provided by an amplifier is measured by its gain, and the gain should be greater than 1 in the case of an amplifier. So it is basically an electronic device that amplifies or increases the voltage, current, or power of a signal. So with this knowledge, we can enter into operational amplifier. Introduction. The term operational amplifier, or OpAmp in short, was coined in the year 1947 by John R. Ragazzini. This OpAmp was originally designed to perform various mathematical operations such as addition, subtraction, multiplication, differentiation, and integration. Hence the name operational amplifier. Since it performs various mathematical operations, we call it as operational amplifier. Nowadays, OpAmp is used in several other applications such as active filters, oscillators, voltage regulators, pulse generators, square wave generators, and many more electronic circuits. It is basically a voltage amplifying device with extremely high gain. As I said earlier, amplifier, the gain should be greater than 1. That is, it should have extremely high gain. So in the case of OpAmp, it is basically a voltage amplifying device with extremely high gain. It can amplify both AC and DC input signals. OpAmp are available in the form of integrated circuits. What are integrated circuits? Integrated circuits are the circuits in which the circuit components such as resistors, capacitors, diodes, transistors, etc. are fabricated on a single small thin chip made of silicon. Hope you all understood the introduction part. Now, block diagram of OpAmp. OpAmp is nothing but operational amplifier. So here you can see the block diagram of OpAmp with the two inputs, differential amplifier, voltage amplifier, output amplifier, and an output, and two power supplies. A typical OpAmp is made up of three types of amplifier circuit. They are differential amplifier, voltage amplifier, and an output amplifier. So differential amplifier is the input stage for the OpAmp. Okay, so you can see here the inverting input and non-inverting input, they are directly connected to the differential amplifier. So we can say differential amplifier is the input stage for the OpAmp. It provides amplification of the difference of the voltages applied between the two inputs. Okay, this differential amplifier provides the amplification of the difference of the voltages between the two inputs. So we have two inputs here, inverting input and non-inverting input. So this differential amplifier provides the amplification of the difference of the voltages between the two inputs. The second stage is the voltage amplifier. Usually class A amplifier is used as the voltage amplifier, and this amplifier provides very high voltage gain. Okay, voltage amplifier provides very high voltage gain. Next comes output amplifier. A push-pull class B amplifier is used for the output stage. So push-pull class B amplifier serves as the output amplifier. It increases the current supplying capability of the OpAmp, and also it provides low output impedance. What is impedance? It is nothing but resistance. So this output amplifier, it increases the current supplying capability of the OpAmp, and it also provides low output impedance. That's all about block diagram of OpAmp. Next comes symbolic representation of OpAmp. So an OpAmp is represented by means of a triangle. The triangle signifies amplification. Okay, triangle signifies amplification. All OpAmps have 5 basic terminals. So 2 terminals for the power supplies, that is plus VCC and minus VEE. These 2 terminals serves as the power supplies, and there are 2 terminals for the input. One is inverting input and the other is non-inverting input. So from the name, inverting input, so the output is precisely 180 degree out of phase to the input. In other words, we can say that when a positive voltage is applied to the circuit as input, then the output of the circuit will be negative. But in the non-inverting amplifier, the output is exactly in phase to the input. That is, when a positive voltage is applied to the circuit as input, then the output of the circuit will also be positive. Okay, so 2 terminals for power supplies, that is plus VCC and minus VEE. They are connected to the DC voltage source. Then 2 input terminals, V1 and V2. The terminal with the negative sign is called inverting input, V1, and the terminal with the positive sign is called non-inverting input, V2. In the inverting amplifier, the output is precisely 180 degree out of phase to the input, and in the non-inverting amplifier, output is exactly in phase to the input, and there is 1 terminal for output, that is V0. So These are the 5 basic terminals of the OpAmp. So you can see in this diagram there is a the terminal with the negative sign. This is called inverting input. The terminal with the positive sign is called non-inverting input. The inverting input, the output is 180-degree out of phase to the input. In the case of non-inverting input, the output is in phase to the input. And we have 2 terminals for power supplies, 1 terminal for output. This is the symbolic representation of OpAmp. Next comes ideal OpAmp. Operational amplifier is basically a DC amplifier whose function is to amplify the difference between the 2 input signals. Okay, so we saw there are 2 inputs. One is inverting input and the other is non-inverting input. So the operational amplifier is basically a DC amplifier whose function is to amplify the difference between the 2 input signals. So in the symbolic representation, we saw inverting input is V1 and non-inverting input is V2. So difference between the 2 inputs means V2 minus V1. Okay. So therefore operational amplifier is also known as differential amplifier. Why differential amplifier? Because operational amplifier, its function is to amplify the difference between the 2 input signals. See here, the term differential comes from the amplifier's ability to amplify the difference of the 2 input signals applied to its inputs. Okay, that is inverting input and the non-inverting input. And only the difference in the 2 signals is amplified. If there is no difference, then the output is 0. Hope you all have understood. See, only the difference in the 2 signals is amplified. If there is no difference, then the output is 0. Now, the difference between the voltages at the non-inverting input V2 and the inverting input V1 is known as the differential input voltage VD. D stands for differential. Okay, so the difference between the voltages at the non-inverting input V2 and the inverting input V1 is known as the differential input voltage VD. Thus VD is equal to V2 minus V1. Now the operational amplifier results in the amplification of the differential input voltage VD by a large gain factor A. Okay, so OpAmp results in the amplification of the differential input voltage by a gain factor A. Therefore, the output voltage with respect to ground is given by VO is equal to A into VD. That is equal to A into V2 minus V1. So here we have VD is equal to V2 minus V1. Thus, in an ideal OpAmp, the output voltage is directly proportional to the difference between the 2 input signals. Okay, if you see this equation, the output voltage is directly proportional to the difference between the two input signals. These are all about ideal op-amp. Next comes practical op-amp. So practical op-amp is the op-amp that is used in the electronic circuits, or that are used for the practical purpose. So IC741 is the most common op-amp used in various electronic circuits. What is IC741? That is integrated circuit 741. Okay, so the IC741 op-amp looks like a chip and it has 8 pins. The pin diagram of IC741 and IC741 op-amp chip is shown below. So this figure A is the pin diagram. You can see a notch over here and there is a dot over the left hand side. So from this dot the number counts, that is 1, 2, 3, 4, 5, 6, 7, 8. Number 1 is offset null, number 2 is inverting input, number 3 is non-inverting input, number 4 is minus VEE, number 5 is offset null, number 6 is output, number 7 is plus VCC, number 8 no connection. So inverting input we give to pin number 2 and non-inverting input we give to pin number 3. 4 we give the negative power supply, and in pin number 7 we give positive power supply. At pin number 6 we measure the output. Okay, and usually this pin number 1, pin number 8 and pin number 5, there is we won't use these 3 pins for the practical purpose. So this is the pin diagram of IC741, which is the practical op-amp, and this is how the IC741 chip looks. So you can see here there is a notch and there is a circle over here. 8 pins are here. So in pin number 2 we give the inverting input, pin number 3 we give non-inverting input, pin number 4 we give negative power supply, pin number 7 we give positive power supply, 6 we measure output. Pin number 1, 5 and 8 we won't use for the practical purpose. Hope you all understood the basics of operational amplifier. Thanks for watching.